Hi, Math 30-2s. Carrying on with perms and combinations today, lesson 5. We start discussing combinations today, okay, and how they differ from permutations. So again, the general idea is that when we are dealing with combinations, order does not matter, okay? And again, that's always the big difference between permutations and combinations. Permutations, order matters when you're being selected to a group or not. So it matters if you're first, second, third, so forth. When we are talking about combinations, order does not matter. Okay, you are just more interested in essence if you are selected to a group or if you are not part of that group. You do not care at what point you are selected or not selected. We're just concerned whether you're part of a group or not. So hopefully that idea becomes a little more clear as we work through today's lesson. If it's not, just email me and we can go over some questions together, or I can answer any questions through email that you might have. So combinations here, part 1. As part of a grade 12 English course, students are required to read the following 3 books in a 3-month period: The Grapes of Wrath, The Wars, The Bean Trees. Part A. Due to previous late returns, Steve is only allowed to sign out 1 English book from the school library per month. List all the different ways in which Steve could sign out the 3 books. So if Steve can sign out only 1 book a month, okay, the order here is going to change depending on the way he takes these books out because it's only 1 a month. So we've seen this before. I have 3 things and I can only remove or select 1 at a time. So order in this case in part A is going to matter here. So I'll use G for Grapes of Wrath, W for Wars, and B for Bean Trees. So that's one way. Okay, another way would be, well, he could still take out Grapes of Wrath the first month, but then maybe he takes out the Bean Trees month 2 and then the Wars month 3. That's a different order. Okay, and then I start with, for example, maybe the Wars. So Wars, Grapes of Wrath, Bean Trees, Wars, Bean Trees, and Grapes of Wrath. And then the final one would be Bean Trees. Start with that book, Grapes of Wrath, the Wars, and then Bean Trees, the Wars, and then Grapes of Wrath. So you can see that in total there are 6 ways, okay? Each of those is a different way that he can remove the books 1 at a time in a month. So 1, 2, 3, 4, 5, 6 different ways. Now in B, it says Tariq is allowed to sign out all 3 books at the same time. How many different ways can he sign out all 3 books at the same time? Well, not a trick question. There's only one way, right? He goes up to the self-serve or to the library and says, I want to take out these 3 books all at once. He can only do that one way. He walks out of the library with those 3 books. We're not talking about the way that they are scanned at the till or anything like that. We're just talking about how can he take out those 3 books. There's only one way. He takes them all 3 in at the same time. So part A that we did with Steve is a permutation. Okay, order is not important. So A was permutation. Okay, order is important. Okay, the second one was combination. Okay, order is not important. Okay, so again, there's kind of the big difference between the two. And then they give you a nice definition here that you can highlight. The selection of a set of elements in which order of the selection is not important is a combination. Now, part 2. Suppose that the students in part 1, so that's Steve and Tariq, were required to read only 2 of the 3 books. Complete the table to show the number of ways in which Steve and Tariq could do this. So what we have here with Steve, okay, is he's just writing down all the different ways he could read 2 books. So he has the Grapes of Wrath, the Wars, the Grapes of Wrath, the Bean Trees. The Wars, the Grapes of Wrath. So then he could also have the Wars here and the Bean Trees. Okay. He could have Bean Trees and Grapes of Wrath. So I'll just shorten it, G-O-W. And then he could also have Bean Trees and the Wars, okay? Now, for Tariq, because he's only taking out the 2 books, but he's taking out 2 books but at the same time, this scenario and this scenario, which were different for Steve because he's only reading 1 per month, is only one combination for Tariq, isn't it? So then what happens is that when I take, for example, I have Bean Trees and Grapes of Wrath, okay, right there, that's the same as this one right here, isn't it? Okay, that's the same for Tariq. Different for Steve because he reads them in different orders in different months, but this one would be Grapes of Wrath and Bean Trees, okay? he taking the books out at the same time, okay? And then the last two would be wars and bean trees. So there's wars and bean trees, and where are wars and bean trees? Right there as well, okay? So different order for Steve because he's reading one per month, but for Tariq, okay, it is the same because he's taking those two books out at the same time. So wars and bean trees. So just taking a look at that before we start to fill in the blank, when we have permutations, you can see there are more ways of doing that compared to combinations. So B, that's kind of what they attempt to show us in the calculations. It says the number of combinations is equal to the number of permutations divided by 2, right? There's half as many. Or when I divide by 2, that's the same as 2 factorial, okay? And we'll take a look at why that number exists and what it is moving forward here. So again, just in general, a permutation is an arrangement in which order is taken into account, and a combination is what the order is not taken into account. Okay, part 3. 5 students, Al, Byron, Colin, Dave, and Eric, take part in a cross-country race to represent their school. So what you're going to see here is that Al is A, Byron is B, Colin is C, Dave is D, and Eric is E. That's how they're going to represent them in the charts, okay? Now, suppose the winner of the race gets $50, the runner-up gets $25, and the third place gets $10. So automatically that's going to be a permutation because first place, there's something associated with first, something associated with second, and something associated with third place, right? You want to finish first versus second versus third. That's very different than if you finish second or you finish third, okay, as opposed to finishing first. Order matters where you finish here. The table below shows all the possible ways in which the 3 prizes could be awarded to the 5 participants. And again, they show you A, Al, B, Byron, C, Colin, D, Dave, and E for Eric. So they give you all the possible scenarios there. Is this an example of a permutation or a combination? Well, like I said, this would be a permutation, okay, because order matters where you finish, okay? How many ways are there to award the prizes? So if you take a look at those, you could simply just count them up. But let's say you didn't know. Well, you would go like this, right? There are 5 runners, A, B, C, D, E, and it's a permutation for first, second, and third. There are 3 places to fill, right? So that's 60 ways. Okay, if you don't like that and you would prefer taking a look at, remember fundamental counting principle, well, I'd have 3 spaces to fill, right? First, second, and third. So I would have 5 choices, 5 runners for first place. Okay, somebody finishes first, so then there would be 4 choices for second place and then 3. So 5 times 4 is 20, times 3 is also 60. Okay, so whether you use straight permutations or use the fundamental counting principle, okay, we get a calculation of 60 possible ways. Now, for participating in the cross-country race, the school has been awarded 3 places at a running clinic. The school coach decides to select 3 participants, okay, from the ones who took part in the race. Table A, which has been duplicated, circle the different ways the students can be chosen. Now, in this case, in this question, order does not matter. You just want to be part of that group that gets to go to the running clinic, or you are going to be left on the outside. So, for example, if you take a look at everything I'm kind of boxing in blue here, those are the same 3 students, A, B, C, A, C, B, B, A, C. It doesn't matter. Those are the 3 students that are going to go. It doesn't matter the order in which the coach would call their names to go to that running clinic. They get to go. Okay, this is another possibility. These are the runners A, B, and D. All of the ones in red there, those are the same 3 runners. All of the ones in black here, those are the same 3 runners, okay? So I think you're getting the idea that the order in which they are selected to go here does not matter. Okay, as long as they are part of the group or not part of the group, that's really what is important here. Okay, so I'm just going to finish doing this, showing you all the different ways that the runners can be selected. Okay, and we'll count them up here. And then last one, here we go. Okay, so how many in total? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are only 10. Okay, there are only 10 ways that those students can be selected to go to the running clinic, and this is an example of a combination because the order does not matter in which they are selected. They are just part of the students going, or they are not part. So complete the following. The number of combinations, okay, which is 10, is equal to the number of permutations divided by what? Well, we had 60 permutations, and we had 10, so we would have divided by 6 or 3 factorial. Okay, remember 3 factorial is 3 times 2 times 1, which is the value of 6. So just like we had a formula for permutations, we have one for combinations. So it looks very similar to permutations, except for that you're going to be dividing by an extra r factorial in the denominator. So that's why there are always less combinations, okay? Because you're dividing by a larger number in the denominator. So to use that, again, we're going to use the NCR key on our calculator, okay, found in the same place that the NPR was, so math, and then scroll to probability. And in some texts, you'll actually see NCR written like this, vertical, the N value over top of the R value. If you see anything notated like that, it is automatically a combination. Permutations are not notated that way. Okay, so make sure you're aware of this point right here. Next, okay, just into some questions. 3 students from a class of 10 are chosen to go on a school trip. In how many ways can they be selected? Write the answer in factorial notation and evaluate. So again, very similar to the running question we just did. You don't care if your name is called out first, second, third, fourth, okay, etc. You just want to be going on that trip or not. Okay, order doesn't matter. You just want to be on the trip versus not being on the trip. So how would we do that? Well, there are how many students? Okay, 10 students in total, and you're selecting 3. So we're choosing 3. I'm not picking 3. So if I take a look at that formula, okay, that's 10 factorial all over 10 minus 3 factorial, which is 7 factorial, and then 3 factorial, right? I just follow that formula. N factorial over n minus r factorial. Okay, and when I do that on my calculator, just please remember to put the denominator in brackets. So that's a value of 120. Okay, and again, use the NCR button on your calculator. So enter the N value, choose, enter the R value. Okay, so that's just 10, choose 3, and you'll see that also gives you 120. To win the Lotto 649, a person must correctly select 6 numbers between 1 to 49. Jasper selected the 6 numbers from the birth dates of his family, 3, 7, 9, 11, 20, 29. How many different selections could he have made? So the numbers he picks doesn't really matter. And whether you know it or not, with a Lotto, you don't have to have the numbers in the correct order. You just have to have them somewhere on your ticket. So that in itself tells you it's a combination and not a permutation. So there are 49 numbers that you could possibly choose, and you only have to choose 6 of them. So on your calculator, 49... choose 6, okay, that's a total of 13,983,816. Okay, next. Now these questions, okay, where they talk about committees, subcommittees, okay, these are very common type questions. So it says, the athletic council decides to form a subcommittee, so a smaller committee, of 7 council members to look at how funds raised should be spent on sports activities at the school. There are a total of 15 council members right now, 9 males and 6 females. The subcommittee must consist of exactly 3 females. So that word exactly is important. It means no more, no less. So I can't have 4 females, I can't have 2 females. I have to have exactly 3 females. So let's see how we can do this. Now it says determine the number of ways of selecting the females. So how many females are there in total? Well, there are 6, right? You can see that right here. There are 6 females. Now, this is a combination. This isn't a permutation because, again, you don't care where you're selected on that committee. There is no president, vice president, treasurer, those types of things. As soon as they start attaching labels to the positions in a group, then it's a permutation, okay? But if you're just on the committee versus not, it's a combination. So there are 6 females, and I have to choose exactly 3 of them. So 6, choose 3. Okay, that gives me 20. So 20 ways that I can do that. Now the males, well, there are 9 males, right? So 9 males, and I have to choose how many. Well, the committee, the subcommittee is going to be 7 people. So if there are 3 females, that means there must be 4 males. So again, 9, choose 4. That's 126. So how many ways are there to form the subcommittee? So this is really the question, part 3. Most times they won't give you kind of step 1, step 2 like they did. They'll just say how many ways are there to form the subcommittee. You in your mind have to go, okay, I'm going to select the females and then the males and then basically multiply them together, right? So then the ways of selecting the females, that was 20. The number of ways to select the males was 126. So I just multiply those 2 values because in your head, remember, you would say I pick the females and then I select the males, and means multiply. So this is 2,520. Now, B, interesting, kind of like a little bit of something special we have to take care of first. Remember your restrictions from permutations, kind of the same thing here. It says, in how many ways can the subcommittee be selected if Bruce, the football coach, has to be included? So that means he is on the committee. So basically you take him and you put him on the committee. Now, that's not going to affect the way that we select the females. So the females will still be, I'll put an F there for females, okay? 6 choose 3. Now, Bruce, the football coach, well, again, you don't have to do this calculation, but again, sometimes visually it's nice to see it. There is one Bruce, the football coach, and I'm selecting him. So 1B1, sorry, that should be 1C1, okay? And that's for Bruce, the football coach. That's the number 1. It's not going to change anything. What it does change is the males, right? The number of males now drops down to 8 because Bruce has been taken out and put on the committee, and I only have to choose 3 more males, okay, because Bruce is on the committee. So when I do those, we know 6 choose 3, that's 20, okay? I know that, okay, like I said, 1 choose 1, that's gonna be 1, that's not gonna affect anything. It's the 8 choose 3, okay, which will give me, okay, 56. So now when I multiply these 3 values together, I get 1,120, okay? So again, that's a very good question. Be aware of that. You'll see things very similar to that on in assignments, homework, worksheets, and on tests. Okay, card questions. So with these, again, these are also very frequent. So if you are familiar with cards and how a deck of cards is comprised of, or what it's comprised of, then you'll be a little further ahead. If not, you'll see this set up enough that hopefully you become familiar with it. And again, if you have any questions about it, just get a hold of me. I'll try and explain it maybe a little bit better than they do here in the book, okay? So a standard deck of cards is 52. There are 4 suits: spades, clubs, diamonds, and hearts. Each suit has 13 cards. So there are 13 spades, 13 clubs, 13 diamonds, and 13 hearts. 2 of the suits are black, so when you flip the cards over, they're actually black, and those are the spades and clubs. 2 of the suits are red, so when you flip them over, you'll see the numbers and the symbols are red. Those are the diamonds and the hearts. And there are what we call face cards in each suit: Jack, Queen, and King. So there are 3 face cards in each suit. Okay, so Jack, Queen, and King for spades, clubs, diamonds, and hearts. Now, poker is a card game played with a deck of 52 cards. How many different 5-card poker hands are possible? So you got to be careful with this, okay? This is going to be a 5-card hand. Sometimes they say 4 cards, sometimes they say 3, but again, when cards are dealt to me, the order in which they're dealt to me does not matter. It just matters what cards I'm looking at in my hand. So as soon as I say the order in which the cards are dealt to me does not matter, that's a combination, that's not a permutation. So there are 52 total cards, and I'm choosing 5 of them to have in my hand. So just 52, choose 5, that's 2,598,960. Okay, so that's a lot of ways that you can get the 5 cards, different ways. Now in B it says, in how many of the hands in A will there be all diamonds? So when I talk about diamonds, how many diamonds are there? There are 13 diamonds, and I want them all to be from that suit. So the calculation is just 13 choose 5. 13 diamonds, I'm choosing all 5 from there. So that's 1,287. Now, in the second question, 4 black cards and 1 red card. Well, the 4 black cards, okay, well, how many black cards are there in the deck? Half of them are black. So there are 26 black cards, and I want to choose 4 of them, 4 black cards. Well, half the deck is red, so there are 26 red cards, and I want to choose 1 of those. So when I do that, okay, the 26 choose 4 is 14,950. And the 26 choose 1 is just going to be 26. Okay, so then I take those values, multiply them together, and you get 388,700. Okay, and there's your calculation there. Next, I got 3 kings and 2 queens. So the 3 kings, well, how many kings are there? There are 4 kings, and I want to choose 3 of them. That's where my 3 kings are. 2 queens, well, there are 4 queens, but I only want to choose 2 of those. So it's going to be 4 choose 3 and 4 choose 2. Okay, so 4 choose 3 is 4. 4 choose 2 is 6. Oops, I lost my pen there. 4 choose 2 is 6. Okay, so that's a total of 24. All right, just about done. 3 kings. Okay, so when they say 3 kings, that's great. That's only 3 cards. So you kind of have to fill in the blanks here a little bit. 3 kings, as soon as they say 3 kings, great, that's 3. I want 5 cards. So what that automatically means is and 2 non-kings, right? So that's kind of what they're saying without saying it. So those are the 2 calculations I have to do. I have to do a calculation that gives me 3 kings and then figure out the non-kings. So here's what happens. The 3 kings, well, there are 4 kings and I want to choose 3 of them. Okay, so there's choosing the 3 kings. Now I have to choose the 2 cards that are not kings. Well, I want to choose those 2 cards from everything that's not a king. So that's 48. Why 48? Well, because there are 52 cards in the deck. I get rid of the 4 cards that are kings. That means there are 48 cards that are not kings, and I want to choose 2 of those. Okay, so that's the calculation here. So these last 3 are a little trickier. So 4 kings, choose 3 of them. 48 that are not kings, and I choose 2 of those. So then I simply go 4, choose 3. Okay, so 4, choose 3 is 4. Okay, and 48, choose 2 will be 1,128. Okay, multiply those values together, you get 4,512. Okay, next, 4 aces. So same thing here. Okay, what are they saying without saying it here? Well, 4 aces, that's great, but you need 5 cards. So you're going to select 4. There are 4 aces. You're going to choose all 4 of them. Now, you have to choose one more card, but you want to choose them from all the cards that are not aces. That's 48. So 48 are not aces, and you're going to choose one that is not an ace. So 4 choose 4 is 1. There's only one way of doing that. 48 choose 1. Well, there's 48 ways of doing that. Okay, that's a pretty simple calculation. That's just 48. Okay, last question. 5 cards all of the same suit, which they call a flush. So I want to have all hearts, all diamonds, all spades, or all clubs. Now notice I'm saying or. So in math, remember or means what? We're going to add. So I have to do the same calculation basically 4 times. Okay, and this is what I mean. So let's say that I dealt with hearts, right? So if it was hearts, there are 13 hearts and I want to choose all 5, right? So I can do that with the hearts, I can do that with the clubs, the diamonds, or the spades. So it's the same calculation 4 times. So you just go 13 choose 5 times 4, okay, and that will give you 5,148. Now, if you don't like that explanation, okay, here's the other one, obviously. Well, you would go 13 choose 5. So that could be your hearts. Or you could go 13 choose 5, and that could be your spades. Or you could have 13 choose 5 for the clubs. Or you could have 13 choose 5. What am I missing? Hearts, spades, clubs, and diamonds. Okay, so you can see it's the same calculation 4 times, and that will still be 5,148. Okay, same end result. So either way that you think about it, okay, you get the same result. And it doesn't matter to me which way you think about it. Obviously, whichever way makes sense in your brain, that's what I want you to kind of focus on. Those are similar calculations though, okay? So that's it for today. That's your first day of combinations.